I'm Mohammad Naji Abu. Welcome to my YouTube channel. In our last video, we have discussed how can we create a data set for Llama 2, okay, and we have uploaded that into our Hugging Face. So here we can see that, okay, this is my Hugging Face account. Here we can see that, okay, this is the data set that we have created earlier in our last video, okay. So that is Wiki Medical Terms Llama 2 format. Okay, here if you expand this, we can see that some instructions and we can see some questions and the answers. Okay, that is how we created this Llama 2 format Wiki medical term data. Okay, so when we go back, so when we go back to my account, we can see that we have a model already, fine-tuned model is already available there in my account, that is Llama 2 fine-tune v2. This is we fine-tune using auto trainer. Okay, so in this video what we are going to do, we are going to fine-tune our model. Okay, we are going to use this particular Llama 2 model. Okay, that is Llama 2 fine-tune v2. This model we are going to use, and this is going to fine-tune against with this particular data set, this Wiki medical term data set. Okay, and we are using the Colab for this one. So I have used A10 GPU. Okay, I have actually 40 GB is available. So let me do a restart here. Okay. So instead of writing here, I have already created a Google Colab notebook. Then we can try to execute all these instructions. Okay, so let me install the things. Okay, so most of the time if you guys are using this, you don't need to change like all those things, just need to change the data set and a few parameters that we can discuss. Okay, so here we are installing the transformers and TRL and bits and byte, PEFT and accelerator, all those things. Now let me install the Hugging Face hub. I believe, okay, that is already installed. Now let me log into my Hugging Face. Okay, so for that I need to give a key. So let me go to my profile. Here, go to here, just go to settings, then token. Okay, so this is my what we called the token. Okay, so maybe I can create another one. I can just give demo. Okay, I can mention the role. So here I need to upload the new model. So I need to select a write command. Okay, I can generate a model, then I can use this particular key. Now let me copy this and paste it here. Okay. Now let me execute this. Okay, so login is done. Okay, now let me execute this cell. Okay, this is basically import. We are importing torch and we are importing the load dataset from dataset and lot of things that we are importing from the transformers. So let me execute the cell. Okay, so the execution is in progress. You can see the memory here also. Okay, let me make it inside. Cool. Okay, so now in our next cell, which is just a lot of configurations or initialization happening here. So here, what will be our base model? So as I mentioned, I am selecting a base model as a model that is already fine-tuned. Okay, so here go to my profile. So this is the model that we are going to fine-tune. You can use like any Llama 2 models. Okay, you can directly use the base Llama 2 model itself. Okay, so but I am using this particular model and this is my data set. Okay, Wiki medical term data set, and this will be my new model. Okay, so let me make it not 23, make it 2 v2. So this is my model, new model. And you can see that there are a lot of parameters are initialized, or like variables are initialized. Okay, so this actually using LoRa and the bits and bytes. So we know that LLM models are like very huge, its weight are like very huge, and training them with minimum resources is like very difficult. So what the people are bringing a new technology that is called the PEFT and the LORA. Okay, it's not a new technology, it's a new method. What they are actually doing, they are actually uh, freezing the existing weight, and they are adding few weights in front of this weights. Okay, and they are actually fine tuning the new added weights, okay, while keeping the original weight as it is. Okay, so that is a method that we are using in the PEFT or the LoRa methods. Okay, so here these are the few parameters that we are using for the particular thing. Okay, so we are using the 4-bit, and this is our output directory. Okay, so output directory will be set as in a result folder, and this is the one parameter that we need to discuss. This is the number of train epochs that is currently set as -1. I will tell you why I set as a -1. Okay, now here are the batch size. Okay, evaluation batch size and gradient checkpoint is set as true, and this is the learning rate. Learning rate can be set as a 2e-4, and weight decay is 0.01, and optimizer is a paged Adam W32-bit, and we are setting the scheduler type as a cosine. Okay, we can set this as a constant also, but this is a standard one. We can go with the cosine, and here this the maximum steps is 50. So since we are using the maximum steps, okay, so even though, for example, let me go to the earlier stage. Here let me set it as a number of epochs as 10 and maximum step as a 50. Okay, so there is usually like people will get confused. So this will not run for the 10 epochs. Okay, this only be run for only the 50 steps it will run. Okay, so if you want to give priority to number of epochs, okay, if you want to run the number of epochs 10, then what you need to do, you need to set the maximum steps as -1. Okay, so in this case this will give priority to the number of epochs. Okay, so but for the demo, let me set it as a maybe 100. Okay, then logging steps are there, and we are taking the device map. So GPU device it will be taking. Okay. So as I mentioned earlier, you don't need to do like much changes with these configurations. Only you need to change with the learning rate if you want, and the number of epochs and maximum steps. Okay, now next step is load the data set. So here we are loading the data set. It's in progress. Okay, that is done. So now let me execute this. We can see that it has a 6861 records are there, and its feature is text. Okay, because its column name is text. Now let me execute this. Okay, here we are setting the bits and byte configurations. We are setting here, and here this model. Okay, this is the one important area where we are loading our base model. Okay, then this base model is fine-tuned with our new data set. Okay, so these are the training arguments that we are using. Okay, all the parameters are set, like output directory, number of epochs. Okay, and all these parameters are assigned with these training arguments. Then we are using the SFT trainer to execute this. Okay, so one thing you have to remember is this is the text field. Okay, in our data set this is the column name text. So if you are giving like a different name, then you have to change it here also. Other than like most of the configurations are fine in our normal scenarios. So let me execute this. Okay, it's in progress. Okay, it may take some time. Let me see, because it has to download our base model. Okay, still executing. Yeah, so it's done. Now we are going to do the actual training. So let me execute this trainer.train. So if you guys remember, we have set it to epochs as 100. Okay, so it started, not epochs 100, like maximum steps. We set the maximum steps as 100. It may takes 3 minutes. Okay, you can see here it is less than 3 minutes. Okay, okay, you can see that how the learning rate is. So let me pause the video. Okay, then yeah, it's still take like 2 seconds. First let me show the loss here. Okay, so after first step, that is 25 steps, its loss is 1.708300. Okay, okay, once after the 100 steps we can see that what is the loss. So maybe let me stop the video. We will join. Okay, now it's getting okay, now it seems to be fast. Okay, seems to be fast now. See, now the training loss is 0.8, so it's learning something. Okay, okay, progressing. 64. Okay, I think we will wait. Okay, 71, 73. So based on data, like it will take more time. So now the loss is very high. Okay, so actually what we can do, we can make maximum steps as -1, and we can give number of epochs as 3. Okay, and we can see that how it learns. Okay, and if you feel like okay the model like didn't learn much, or its learning rate is very less, then what we can do, we can increase gradually, we can increase the epochs, maybe 3, then 5, then 10, like that. Okay, okay. Here the training is done. We can see the training loss is like 1.17. training loss is there, so we just did only 4 steps. Okay, maybe I can make it 10 or 20 to get more accurate values. Now here let me save the model. Okay, model is saved. Okay, this is the V2, this is the model, this is the old model, this is the new model. Okay, V2. Here we can see that only the weights, new weights are saving. Okay, so let me try something here. Let me give, okay, now the model is ready. Now let me scroll down. Okay, Now what we are going to do, we are going to give some query here. We are going to ask some prompt here with this new model. Okay, for that we are using the pipeline. So this is my prompt. What is the paracetamol poisoning, and explain in detail. And this is the pipeline that we are going to use. So this is our new model, and this is our tokenizer, and I have set the maximum token length as 300, I believe. 300. Okay, so now let me execute this. I'm executing this. We can see that it's a result. Okay, so it's in progress. Okay, it may take usually like 25 to 35 seconds. Okay, so in our real scenarios, what we will do, we will stream this result. So see, like if we ask something to OpenAI or ChatGPT, it is actually streaming the data, right? So when we do a production ready LLM models, fine tuned model, we will try to stream it. So the users no need to wait for like 25 seconds. Okay, they will get like a streamed data. Okay, so it will give like more user experience. Okay, so this is the what we call the prompt that we have asked, and this is the result. Okay, see, the result is started from here. It says that the poisoning is also known as poisoning in the medical conditions that occurs. Okay, all those details are there. It's learning something, or it's learned something, and I cross-checked this seems to be fine. Okay, but to get like more data or more accurate result, we have to train the model with more epochs. Okay, now what we are going to do next here. Okay, so here as I mentioned, this is the only small weight. This is the new weight that is in this particular folder that we have saved. Now what we are going to do, we are going to merge this weight with the original base model weight. Then we will get the entire standalone model. Okay, so that is what we are going to do. So first let me clean the memory here. So this is used to help us to clean the memory. Otherwise, if you are using like T2 or something like that, you may get like error, memory error. So I'm just cleaning up everything. Then what I am going to do next is, okay, so this is our base model. Okay, so this is our base model, and this is our LoRa model. So what we are doing here, we are actually taking our base model and we are merging it with the new weights. Okay, so this is the merge and unload. This is the method that we are going to use this for the merging purpose. Now let me run this. Okay, here I am getting an error. Let me see that. Okay, so something is went wrong. Let me check here. Okay, trainer is not there, so it is not working. Okay, I'm checking this error. Let me check this error. LLama2 video does not appear. I have a file named config.js checkout phase tool for the files. Okay. Okay, here there is a small problem. Okay, here I have given like both of this, I have given the same name. Okay, so what I will do, let me change this to 3. Okay, now I will repeat all the steps again. Okay, so let me pause the video, then After running all those things, we will join back. Okay. So as I mentioned, what I have done, I just changed my new model name. Okay, here I have changed a new model name as V3. Okay, earlier like the model name and the new model name was same. Okay, so I changed the new model name is different from the our base model name. Okay, then I have executed all the statements, all the cells. Okay, now the training is done. Okay, now this is also done. Now I am going to make it empty. See what will happen this time. Okay, now I am going to merge the model. Okay, the new weight and the old weight, I mean the frozen weight. So these are going to merge together. Okay, we will get a new model, new independent model. So it's in progress. It also will take some time. Okay, it's progressing. So once it is done, what we will do, we will push this to Hugging Face Hub. Okay. Okay, so this cell is done. Now let me push the model and the tokenizer to Hugging Face. Okay. So in the right side, you can see that how much memory it is using. Okay, it is only using 14.9 GB of RAM. So you don't need to use A100. Okay, we can use T2 or V2 can be used. Okay, since it's taking only like 14.9 GB, I took A100 to get executed is very faster. It's actually will take like 13.08 points per hour. Okay, if you select T2, it is only taking 2 point something. Okay, per hour. Okay, this is actually huge. Okay, so it's not showing any progress, but it's executing. So if you go to our Hugging Face hub, okay, go to Abu Naji, we can see that a repo is created, a model repo is created. Okay, this is now this is 1 minute ago this is created and this is empty. Okay. Okay. We'll wait. Yeah, started pushing. Okay. See, this is actually 9.9 GB, then it has a 3.50 GB. Okay. Okay, based on the network speed, it may take some time. Okay. See, once this is pushed, we can use this for the inferencing. Okay. So still in progress. So about this token, okay, about token, okay, what I will do once this video is uploaded, I will be removing this particular token, okay, access token. So don't use my access token. You can create a Hugging Face account that is for free. Then you can do all these exercises, okay. In Colab, one more thing, in Colab, I am using actually a paid version, okay. To use high RAM, I believe a T2 may be available, but I'm not sure. We will not get like 15 GB RAM in free version, but just try it, okay. So what we'll do, we'll pause the video, okay. We will join back once it's done, okay. The model pushing is done. So we have pushed model and the tokenizer to our GitHub repository. Not GitHub repository, sorry, Hugging Face repository. So we can go to the Hugging Face models here. Okay. So this is our new model v3. Open it, just go to the files and versions. We can see that okay, the files are uploaded. Okay, tokenizer and everything is uploaded, and this model can be used for the inferencing. Okay, so that is all about in this video. Please do like and subscribe. Have a nice day. Bye bye.